In this problem, you've been asked to find the area of region R. And so hopefully, many of you thought to do this with vertical rectangles, and then think of it as an R1 and an R2 with two different upper curves. First thing you need to do is find out where these two curves intersect. This is what the AP board put on their key to that many decimal points. You don't need to show that many, but you have to show at least 3 decimal points. And you can also call this A and call this B for later in your work. That's what I'll do. So my first integral would run from 1 to point A, which is 3.693, and it will be the upper curve, which was ln of x, and we would add that area, so this is really region 1 plus the integral from where they cross, 1.369. So I'll use A just to save time, and you can do this on your final and the actual AP test. And this hits over here at 5. You can count it over, or you could plug it in here at 5 and see that 5 minus 5 is 0. And that's the other upper curve, 5 minus x. Go back and make sure we've included dx everywhere. And now I will put this in my calculator using Math 9. And when I do, my answer will be 2.986 or 2.985. In other words, you don't have to round, you can truncate and just cut off the last 3 decimal points, but to get full credit, you needed to show 3 decimal points here and at least 3 decimal points to your limits. Now there's another way to do this problem, and that could also be to horizontally integrate this with rectangles running across. Our height would then be dy. Now we'd be integrating from 0 to this 1.306 or b, and we be going from the right curve, which was x on the right minus x on the left, dy. The last thing would be to solve these for y. If y equals 5 minus x, then x equals 5 minus y, so that would go here. And if y equals ln of x, then x would equal e to the y, because we would need to exponentiate to get x all by itself. Essentially, we'd be doing e here and e there. And so the final answer this way would be 0 to b of the right curve, 5 minus y, minus e to the y dy. And when you integrate, you get the same answers both ways.